A sprig of rosemary sits on a cutting board beside a roasting pan. The cook strips the leaves from the stem, scatters them across vegetables, and slides the tray into the oven. Within minutes, the kitchen fills with a sharp, resinous scent that seems to sharpen the air itself. This happens in kitchens everywhere, several times a week without much thought. Rosemary is treated as seasoning, a finishing touch, an aromatic accent that makes food taste better. But that scent carries more than flavor. Inside those needle-like leaves lies a collection of molecules so biochemically active that for thousands of years, rosemary was not considered food at all. It was medicine. Greek scholars wore it woven into their hair during examinations, believing it strengthened memory and focus. Roman priests burned it in temples as part of purification rituals. Egyptian tombs dating to 3000 BCE contain traces of rosemary placed alongside the dead, preserved in burial chambers for reasons that went far beyond symbolism. Across centuries, across continents, the same plant appeared wherever humans sought clarity, protection, or preservation. Then modern medicine arrived. Pharmaceuticals replaced plant knowledge. Standardization replaced observation. Patents replaced gardens. Rosemary remained in kitchens, but its medicinal identity faded into folklore. Not because it stopped working, because it could not be controlled, measured, or owned in the way the new system required. For decades, rosemary existed in a strange, liminal space. Too common to be taken seriously, too ancient to be entirely forgotten. But in recent years, something shifted. Neuroscientists began isolating the compounds inside rosemary and testing them in controlled environments. What they found was not folklore, it was biochemistry. Molecules that cross the blood-brain barrier. Compounds that modulate inflammation at the cellular level. Pathways that regulate glucose metabolism and stress response. The Greeks were not superstitious, they were observant. And what they observed, science is now beginning to confirm. This is the story of what happens when a kitchen herb stops being decoration and becomes something far more interesting. To understand what rosemary actually does inside the human body, it helps to begin not in a laboratory, but in a place where its effects were observed long before anyone understood the chemistry behind them. Athens, sometime around the 4th century BCE. Young men preparing for philosophical examinations would weave fresh sprigs of rosemary into their hair and tuck them behind their ears while they studied. This was not decoration and it was not ritual in the mystical sense, it was practical. They believed the plant sharpened memory and improved their ability to retain complex arguments during long oral defenses. The practice spread throughout the Mediterranean. Roman students adopted it. So did scholars in medieval Europe, where rosemary became so closely associated with memory that it appeared in wedding ceremonies as a symbol of fidelity and in funerals as a token of remembrance. Even earlier in Egypt, rosemary appeared in tombs dating back 3 millennia. Archaeologists have found traces of it carefully placed alongside the dead, preserved in burial chambers where only materials of significant value were included. Across centuries and across cultures separated by vast distances, the same plant kept appearing in contexts that demanded mental clarity, preservation, and protection. This was not coincidence. It was the result of sustained observation passed down through generations. But as modern pharmacology developed during the 19th and 20th centuries, that kind of knowledge began to lose credibility. The new system required standardization, precise dosing, and compounds that could be patented and controlled. Plant-based medicine, with its variable potency and inability to be owned, did not fit the emerging industrial model. Rosemary remained in kitchens because it was useful there, but its identity as a medicinal plant faded into the background, relegated to the category of folk remedy, a polite term that often means unproven or superstition, not because rosemary stopped working. It never stopped working. But because it could not be monetized in the way synthetic pharmaceuticals could, and because the knowledge surrounding it existed outside the institutions that now controlled medical legitimacy. For most of the 20th century, rosemary was simply seasoning. Then neuroscientists began asking a different kind of question. What if the ancient observers were not imagining the effects they described? What if rosemary actually was doing something measurable inside the brain, and the Greeks simply lacked the tools to explain how? Researchers began isolating the individual compounds inside rosemary to see which ones, if any, could account for the cognitive effects reported across so many centuries. One molecule stood out almost immediately: carnosic acid, a diterpene compound concentrated in the leaves. What made carnosic acid unusual was not just its antioxidant capacity, which many plant compounds possess, but its ability to cross the blood-brain barrier. The blood-brain barrier exists as a protective filter, preventing most substances circulating in the bloodstream from entering the delicate tissue of the brain. This barrier blocks toxins, pathogens, and the majority of pharmaceutical compounds. It is one of the reasons developing drugs for neurological conditions remains so difficult. Carnosic acid passes through. Once inside the brain, it activates a cellular defense pathway known as NRF2, which upregulates the production of endogenous antioxidant enzymes. In simpler terms, carnosic acid tells brain cells to strengthen their own protective systems before damage occurs. Studies have shown that it reduces neuronal death, ameliorates brain edema, and protects against oxidative stress in models of neurodegeneration. This is not stimulation. It does not force the brain to work harder or faster. Instead, it reinforces the mechanisms that keep neurons alive and functional under stress. The Greeks could not have known about the blood-brain barrier or the NRF2 pathway, but they observed the outcome clearly enough to build a tradition around it that lasted for centuries. Modern neuroscience is now confirming what they saw. Rosemary contains another compound that operates through a different but equally important pathway: rosmarinic acid, a polyphenol with potent anti-inflammatory properties. Inflammation is often visible when it appears as swelling, redness, or pain in response to injury or infection. But much of the inflammation that drives chronic disease operates silently, at low levels over years or decades. This kind of inflammation contributes to arthritis, cardiovascular disease, metabolic dysfunction, and neurodegeneration. Rosmarinic acid intervenes directly in the inflammatory cascade by blocking the enzymes responsible for triggering tissue irritation and immune overreaction. In preclinical studies, researchers tested rosemary extract and isolated rosmarinic acid across multiple models of inflammation, including arthritis, colitis, and neuropathic pain. The results consistently showed reductions in inflammatory markers and improvements in tissue health. A systematic review published in 2022 examined dozens of studies using animal models of inflammation and found that rosemary, whether used as a whole extract or as isolated compounds, demonstrated measurable anti-inflammatory effects across nearly every model tested. When consumed regularly, rosmarinic acid acts as a biological dampener, reducing the intensity of inflammatory signals before they accumulate into chronic conditions. This does not mean rosemary replaces medical treatment for inflammatory diseases, but it does suggest that daily consumption may help modulate the baseline inflammatory state of the body, creating an environment where chronic inflammation is less likely to take hold in the first place. In 2015, researchers in Iran conducted a randomized comparative trial that tested whether rosemary oil could match the effectiveness of minoxidil, the active ingredient in Rogaine, and one of the few FDA-approved treatments for hair loss. 100 patients with androgenetic alopecia, the genetic pattern of hair thinning that affects both men and women, were divided into two groups. Half applied rosemary oil to their scalps twice daily. The other half applied minoxidil at a concentration of 2%, following the same schedule. The trial lasted 6 months. Participants returned to the clinic every 3 months for standardized microphotographic assessment and hair count analysis. At the end of the study, both groups showed similar increases in hair count. The difference between them was not statistically significant, meaning rosemary oil performed as well as the pharmaceutical standard. But there was one notable distinction. The group using rosemary oil reported significantly less scalp itching compared to those using minoxidil, a common side effect of the drug. The mechanism behind rosemary's effect appears to involve improved microcapillary perfusion, meaning better blood flow to the hair follicles. It does not force growth through hormonal manipulation. Instead, it restores circulation to areas where blood flow has diminished, allowing dormant follicles to reactivate naturally. A natural compound matched a pharmaceutical intervention without the associated irritation. Chronic stress does not simply feel uncomfortable. It alters physiology. When stress becomes sustained, the body releases cortisol continuously, and elevated cortisol over time damages immune function, disrupts sleep, impairs memory, and accelerates cellular aging. Researchers wanted to know whether rosemary could influence this process measurably. In a double-blind crossover trial published in 2024, 40 participants consumed rosemary extract daily for 4 weeks. The study measured both psychological markers, using standardized anxiety inventories, and physiological markers, including heart rate variability, which reflects how well the nervous system adapts to stress. After 4 weeks, participants showed significant improvements in trait anxiety scores and measurable changes in heart rate variability, indicating that their autonomic nervous systems had become more balanced. An earlier study from 2007 took a simpler approach. Researchers asked participants to inhale the aroma of rosemary essential oil for 5 minutes, then measured cortisol levels in their saliva. Compared to a control group that inhaled a neutral compound, those exposed to rosemary showed a 23% reduction in salivary cortisol. Rosemary does not sedate the nervous system. It does not dull alertness or slow reaction time. Instead, it appears to modulate the stress response itself, allowing the body to remain alert without becoming hyperreactive. The body stays engaged, but the internal alarm system quiets. Rosemary also interacts with one of the body's most fundamental processes, how cells use glucose for energy. Carnosic acid and related compounds found in rosemary, including carnosol and rosmanol, activate a cellular energy sensor called AMPK. This enzyme regulates how muscle cells absorb glucose from the bloodstream and how efficiently they convert it into usable energy. In studies using muscle cell cultures, researchers expose cells to high levels of glucose and insulin, conditions that typically lead to insulin resistance, where cells stop responding properly to insulin signals. When carnosic acid was introduced, it attenuated this resistance, helping cells maintain their ability to take up glucose even under metabolic stress. A review published in 2017 examined the anti-hyperglycemic potential of rosemary extract and found that its polyphenolic compounds behave similarly to certain diabetes medications, inhibiting enzymes that break down carbohydrates into sugars. This slows the rate at which blood sugar rises after meals and improves overall insulin sensitivity. The effect is not dramatic in the way a pharmaceutical intervention would be. Rosemary does not replace diabetes medication, and it should not be treated as a substitute for medical management of blood sugar disorders. But the evidence suggests that regular consumption supports metabolic regulation at the cellular level, helping the body maintain steadier energy release and reducing the likelihood of the sharp glucose spikes that, over time, contribute to insulin resistance and metabolic syndrome. The body shifts from reactive surges to regulated flow. The timing of this rediscovery is not accidental. Neurodegenerative diseases are rising globally. Alzheimer's and other forms of dementia now affect tens of millions of people, with projections suggesting those numbers will triple by mid-century. Chronic inflammation underlies most of the leading causes of death in developed nations, including heart disease, diabetes, and cancer. Metabolic syndrome affects nearly 1 in 3 adults in many countries. Stress-related health decline has become so widespread that it is now considered a public health crisis. Pharmaceutical interventions remain essential, and modern medicine has extended human lifespan dramatically. But the system is also showing strain. Many of the most common chronic conditions are not cured by medication. They are managed, often for decades, with drugs that address symptoms rather than underlying causes. Rosemary represents something different. It is not a pharmaceutical replacement, and it should never be treated as one. But it does offer a low-intervention, biologically active option that cooperates with the body's existing regulatory systems rather than overriding them. It does not force neurons to fire faster. It protects them from oxidative damage. It does not suppress inflammation artificially. It modulates the signaling pathways that control inflammatory response. It does not manipulate insulin production. It improves how cells respond to the insulin already present. and it has been sitting in kitchens, gardens, and markets for thousands of years. Incorporating rosemary into daily life does not require supplements or extracts, though those exist. Fresh rosemary can be added to soups, roasted vegetables, and teas. Dried rosemary retains many of its active compounds and works just as well in most culinary applications. Rosemary oil, when diluted properly, can be applied topically to the scalp for those interested in the hair growth effects observed in clinical trials. What matters more than quantity is consistency. Small amounts consumed regularly appear to be more effective than occasional large doses. This aligns with how traditional cultures used the plant, not as an emergency intervention, but as a steady presence woven into daily routines. The woman who began adding rosemary to her meals every day did not experience a sudden transformation. She experienced something quieter and more gradual, a return to balance that became noticeable only after weeks had passed. Her memory sharpened because the neurons in her brain were better protected from oxidative stress. Her inflammation markers dropped because the signaling pathways that trigger chronic immune activation were being modulated at the cellular level. Her stress response softened because her cortisol regulation improved, allowing her nervous system to remain engaged without becoming overwhelmed. Not because rosemary is magic, because it contains molecules that interact with human biology in ways we are only beginning to map in detail. The Greeks were not superstitious when they wove rosemary into their hair before examinations. They were observant. They noticed patterns that repeated across individuals and across generations, and they built practices around those observations. Modern science is now confirming what they saw, using tools and language they could never have imagined. Sometimes the most powerful interventions are not the newest ones. Sometimes they have been growing quietly in the garden all along, waiting for us to remember what they were always capable of doing.